for joining the ZP Julie webinar this afternoon. We've got a few slides, but we've also got a lot of demos. So what I'll do is just a FYI, we're actually having the Scandinavia Sensor Summit next week. This is a conference, we sort of say digitization for a sustainable future. I mean, if I was to sort of summarize it, we think sensors are really important. You know, we can measure things and we can send that data to the cloud. So sustainability can mean, you know, environmental agriculture, but it can also mean kind of health at the same time as well. Topics that we're going to cover today, I'm going to do a quick introduction, but then we're going to do some actual demos. We're going to do a slight difference in order that Lynn is going to do amperometry. We're also going to do cyclovoltammetry. We're also going to do cyclovoltammetry when it comes to manufacturing. So if your assay kind of involves voltammetry, this will be super interesting to you. If it involves amperometry, it'll be super interesting to you. Tatiana is also going to do EIS, electrochemical impedance spectroscopy. And we're also going to do a demonstration from Guyana on the Sense-it-all platform. So Sense-it-all, we'll discuss it, but it's making a measurement at the point of need and that data going immediately to the cloud. And there's a little bit of a demo on that as well. It's probably worth saying there's a dedicated webinar to this tomorrow on Sense-it-all, but today we'll just do a quicker one. So quick introduction for myself. This order was just slightly changed with Lynn going first, but otherwise, just want to say ZP, you know, this is our 9th year. I think in November we'll be 9 years old. So we've been around doing ISO 13485 contract development, contract manufacture for a little while. Team is fairly large. Actually, quite a few of the team are online today. It's probably worth saying we got some strength in depth because one of the architects of Julie isn't here this afternoon, but you know, obviously then we have more people to demo this kind of technology, and it's something that we find quite easy to demo because actually we use it quite a bit. Not quite a bit, we use it every day. ZP has state-of-the-art facilities in Norway and in the UK, you know, class 7 clean rooms, etc. So we're really kind of set up for doing electrochemical sensor development. What's at the heart of what we do is actually, you know, data. We don't think that the sensor itself is the end game here. We really think that the data and the information is actually the end game here. So Julie is something that has been with us almost from day one. You know, it was coded very basically at the start, but it's matured over the years. I used to call Julie a database, but that's really not fair. It's a data management system where we do use it. So if you're a client of ours, you will find that we're putting all the data up to there. So it's data storage, but it's also data visualization. So you can kind of, you know, electrochemical data is often just a string of numbers or 2 columns. One of the columns will be time or potential, for example, and the other column might be current or potential. But it's a quick way of visualizing those kind of strings of data. We process it. You'll see Lynn doing baseline offset today. You'll see we've also got Vanessa, who's going to talk about cyclovoltammetry. You'll see Vanessa use it to do quality control in our manufacturing. Data acquisition, you'll see Ghana make a measurement today, and that data will immediately go to Julie. And you know, we do know how to play nicely because we do have an API application program interface as well. So that's really useful. If somebody's in their early days of development and they need to get the data off our cloud into their cloud, they can make an API call upon us as long as they've got the credentials, i.e. it's their account. We find it really useful because if we're gathering data in our lab, or at the same time, if you're gathering data and we need to see your data, Julie's really useful. So we could be working with clients, and for some reason, we had a client today, you know, they've got blood samples. It's not like they're going to be able to ship those blood samples to us, so they're going to have to do the testing, but it means that we can actually then see the data. Another one, we're doing a hospital test at the moment. They're gathering the data and we're seeing the data in real time. We've got another client where it may be hard to actually source the small molecule because it's on one of these kind of controlled lists. They might have to do the data and we can see the data in real time. So Julie's a great way of seeing the data. Julie, we try to help people kind of get familiar with Julie by having a freemium versus premium. Difference being is freemium is free, premium is 99 euros per month. You'll see us talk about reports today. So freemium is very limited on reports. You kind of have 8 reports, 5 flexible and 3 inflexible. With the premium version, it's unlimited. There'll be tools. You'll see Lynn do an offset, a baseline offset. You'll see statistical analysis done by our guys. You'll see them using filters. These tools are available both for freemium and premium. You'll see reports like you make 50 sensors. What's the repeatability? You know, those are the kind of reports that we can do. What's important as well is templates, so that for me, this is quite important that if you use your intellect to decide how you want to see your data, you can fix that so then that you can use other people to gather data for you, but you'll get the data in the way that you want it. And that's what templates really allow us to see. We have AC. So AC means I'm doing amperometric data and it's continuous. So an example of that would be a oxygen, glucose, lactate type sensor. PC, potentiometric, continuous. So something like that would be pH, sodium, potassium. But we also have discrete data, and that would be things like voltammetry, which we call discrete. So that said, freemium and premium both have availability to that. The database can also just deal with generic data. So let's say you were using, and this is not necessarily applicable to the people listening to this webinar, watching this webinar this afternoon, but let's say the signal was wavelength or intensity versus time. We can actually deal with that as well. So the database is sort of more generic than just electrochemistry, though I would say that it is optimized for electrochemical data. What's nice about the full access is that if we upload data, you can download the data. So it's a nice way of doing essentially data transfer rather than just sort of using email or Dropbox. It's kind of, you can curate the data and then somebody else can download the data and analyze the data elsewhere. You can download reports if you're freemium or premium. You can delete reports. The thing about freemium is you soon fill up freemium, whereas premium, you've kind of got the ability to delete reports when you want to. You can make new projects. There's a kind of an architecture to this. There's clusters, projects, and reports. You'll see that happening today. You're limited on the freemium, but you're unlimited on the premium. And you can edit reports in premium, create clusters, which is part of the architecture. And also you can do comparative reports. Now, a comparative report would be, I've just manufactured a batch of electrodes. I can analyze them. A month later, I analyze another batch of electrodes. I can compare them. Now compare those two batches and tell me the difference between them. So that's what a comparative report would be like. And you've got limitations on freemium, and on premium you have unlimited. Freemium also has an expiry date on it. It expires after 30 days. Now, Julie, first of all, that does answer an important question, which is you're either working independently of us or you're working with us, but you can ask the question, where is my data? And if it's voltammetry, your data is being gathered either in our lab, in your lab, or maybe on something like the SenseIt platform, and it's all going to Julie. So the question, where is my data? And this is such a serious question because so many companies, either companies, startups, academics, it's really a mix of where the hell the data is. But at least with Julie, it's actually organized that we know where the data is. That's part of obviously the value to know where data is. Because it's in Julie, we can kind of view it through smart devices because it's essentially browser based. You can view the data. So, even though the instruments might give out a string of numbers, we can view it. This is voltammetry. There's something like 50, well, there's in the total steps here, there'll be something like 50 CVs, and we can eyeball them or what they look like, but we can also analyze them. So for example, here we want to look at repeatability. So we can look at sort of peak height, and Julie will tell us what's our mean distribution of peak height, what's our median, what's our standard deviation. Julie can analyze all that, and that's what's happening here. What's my mean? What's my standard deviation? What's my relative standard deviation, which is 7% here? What's my median? What's my min? What's my max? So, we can go in the lab, gather 50 data sets, upload it to Julie, and it will immediately crunch them. Even if you're a client of ours, you can see the fact that we're using Julie is saving you time just on the data crunching back end of it. Here's a sort of more representative, whole stack of data which we can do. And we can also do kind of quality control. So at ZP, we absolutely believe we're making the best screen printed electrode possible, or in the world, I would say. We do things like we make the sensors, then we do quality control, and then we ask questions like, what's our peak to peak separation? And what's our peak to peak what's the peak-to-peak separation and what's the peak-to-peak intensity. And we ask questions of it, and then we can run feature checks to say, you know, there's a certain criteria or there's a certain feature, there's a criteria, are we going to pass or fail that? Now, I shouldn't say too much on that because Vanessa will actually kick in and talk about that as well. If we're looking at a signal versus some sort of variable, Julie will allow us to look at that variable as a function, well, the signal as a function of that variable. So we can go do standard calibration graphs. So, for example, we do work with a lot of people. The only reason that we sometimes promote voltammetry quite a lot, this is a particular molecule that we work with. It's got a lot of features in its data, and these features are kind of indicative of that particular molecule. This is, I know we do a lot of talks on capsaicin. This is not capsaicin. This is another molecule. It doesn't have the distinct peaks that appear on the second scan. But we're able to, with Julie, able to look at this signal. This is in triplicate, by the way. So each, they say the color coding is indicating that there are actually 3 individual electrodes there. The reason this is quite good is because it's the electrodes are so repeatable the way we manufacture them. But what's happening here is we're looking at this data versus concentration for triplicate results. And Julie is able to kind of go in there, and we're able to sort of come up with a calibration curve quickly because Julie can kind of automate that. Lynn will show you an example today of a glucose sensor where we've calibrated the glucose sensor, and then Lynn is able to analyze the data and to show what the calibration curve actually would look like. So what we'll do with a glucose sensor is we will gather signal, we'll change the concentration, we'll gather signal, we'll change the concentration, we'll gather signal, we'll change the concentration, and then we're able to go in there, tell Julie what those concentrations were, and then Julie will actually give us a calibration curve back. I did touch on this earlier on, but we also use it in manufacturing a lot to ask questions of our manufacturing to make sure that we're essentially staying within spec. What's our peak-to-peak separation? It has to be within a certain limit. If it's within that limit, then we can pass it, and then look at other features like peak height to make sure that they're over a certain sensitivity, and if they are, then we'll pass them, for example. Lastly, on API, Julie does have an API built into it, so as long as it's your account and you've got the credentials, you can pull that data across to whatever cloud you wanted to do. So I say here demo. We do have a slight change in order. So what I'll do is I'll stop sharing. I'll turn off my camera, turn off my mic, and Lynn will kick in and do a quick demonstration on one way that we use Julie. So if you want to do that, Lynn.
Yeah, sure. Thank you, Martin. So now I'm going to show you how we are going to deal with the continuous data. So as we know that chronal amperometry is highly useful for the most of the electrochemical analysis, especially for glucose and oxygen detection. So in this Julie report, we are demonstrating one of our batch produced in our company to our clients, that like we are using a different batch of enzyme, and then we want to see whether the old enzyme functioning the same as the new enzyme we purchased. So in this experiment, you can see that like first of all, we will need to enable the edit mode, and then we need to click the tools so that we can upload our data in this box. We can either adding our file by click this icon or drag the file into this empty place. After that, you just need to simply go to the next button, which is the property, and tell Julie that we are doing the amperometry. The reason why we need to tell Julie is because you can upload multiple methods into one file, and then ask Julie that like we can analyze the different methods at the same time. So in this report, it's just a simply amperometric method. So after you click this amperometric method in this continuous study, this AC, which is amperometric icon, will show up. And after you click it on, you will see quite a few selections there. So you can tell like Julie what state of the measurement you want it to be. For example, it can be the pre-status, like before you adding any enzyme, or like after status. So that is for comparison purpose, but for most of the cases, we just have a one state. And in terms of access, for example, if you want to view your data differently, you can tell the output to be set it into different units. The pre-processing is what Martin mentioned, that like we can do a baseline correction using the offset, because as you can see here, that like a different data, they have a different offset. So for a better visualization to compare the sensitivity, what I normally do is I bring the offset between 250 to 900 down to 0, so that I can visually see the difference. So what will happen is after I close this one, you will see that like everything is brought down to the baseline, so that like you can see the green one has a highest sensitivity just by visually compare. So the other important thing is that like because we are doing the spiking, which is one of the quality control we did before we sending the sensors to the customers. So what we have here is we need to configure the events, so that I just show you here that like on the configuration, we need to tell Julie that like this is our 0 millimolar by using the configure button. And we just also tell it like after so in the experiment, we normally know like when we adding the next spike, so that we can increase the another bar into this report to indicate like okay, I add another 2 millimolar, and after 150 seconds I know I add another 2 millimolar, so I'm doing the stepping up constant spiking in the glucose concentration all the way up to 6 millimolar. So after I close this report, this tool, so what I have here is I will have a linear plot. This will show me how your data are scattering, and also what is my LOD. So I just need to simply place my cursor here, and then I will see my LOD is around 2 millimolar on this particular batch. There will be like more comprehensive report down here. So we have a independent statistical evaluation that comparing sensor to sensor, so that we know like how each sensor are functioning. And also for more visualization, and also for maybe FDA purpose, we normally have this more box plot that to just to show people that like we how scattered one batch are before the clinical trial. And also in this plot, you can see our mean value for each concentration and the standard deviation, and also so how many data presented in each concentration. So we normally use this report for FDA purpose. So this gives us a really easy access. If we want to download the report, you just click the 3 dots, and you just download the analysis results. This once you click in, it will be downloaded either by PDF, like this one. It will pop up a PDF icon, and you can just ask it to do A4, and also if you want to have a signature there for the quality control purpose, you also have that option. So that is everything for chrono amplimetry.
Yeah, I appreciate that, Lynn. And if you're watching along, don't worry about it too much, because we are recording, and we will put this online later on. So thanks, Lynn. So I think the next one we have on cyclovoltammetry is, I believe it's Vanessa. So anyone who's doing a sort of voltammetric assay, this will be super interesting. The nice thing about the guys is they're so articulate on it because they use it every day. So Vanessa, do you want to share screen and take over, and I'll be quiet, as they say.
Yes, thank you, Martin. Okay. So, hi, I'm Vanessa. I'm an engineer here at Simron Peacock, and today I'll give you a quick demonstration on how you can use Julie for analyzing discrete data from cyclical telemetry. And as an example, I have some data that I have obtained from our own screen-printed electrodes tested with the Ferry Sinus solution in order to test their performance. Okay, so I wanted to kind of do this from scratch as Lynn did. I've already uploaded the data, and we now go on and select the discrete voltammetry study. And what we can see here is that we get, these voltammograms. Displayed here. And so in this particular experiment, I have ran two cyclic voltammetry scans on each sensor, as you can see here. But let's say I'm only interested in scan number 2 for each of the sensors. So we can easily display only the second one by selecting spatial mapping and scan number 2. And there we have a more clearer picture of what we'd like to analyze. And the analysis itself is also quite easily done. We can, for example, select the peak height fit and specify the window where our peaks should be. And we can include a statistical evaluation. So what we get now is some statistics with, as Martin said earlier, we get mean value and the standard deviation, relative standard deviation, median, minimum and maximum values, as well as the sample size. And also we get this distribution and these mapping overviews, which I'll talk about later.
So when you mentioned talking about sorry, yeah, go ahead, sorry.
Oh, yeah, okay. And I wanted to show you another handy tool that I use a lot, which is the feature check option, in which we can check whether a sensor has passed a certain criteria. I can, for example, check whether the peak height here is, for example, greater than, say, 5 microamps. Select where the peak should be. And here I get a full list of the sensors. I get what kind of criteria I've set, and I got the actual peak height of those scans. And here Julie has already checked for me whether the sensor has passed that criteria or not. Here we can see one did not pass this criteria, and it's automatically a fail. So this makes it a lot more easier to analyze big sets of data. And anyways, I think that's all for the discrete data. Should I continue with the manufacturing, Martin?
Yeah, that's a good idea. So don't worry if you've joined late this afternoon. We are recording this. There's an awful lot of information coming out in this sort of approximate 45-minute webinar. So don't be, let's say, too stressed by following it all, because we're recording it. We'll send anyone who's registered a copy later on. But I agree, Vanessa. If you go on now to sort of, you know, we can analyze voltammograms for the sake of an assay, but we can also analyze voltammograms as a quality control tool in the manufacturing, which is what we do. So yeah, if you can go on to say how we use it in manufacturing, that would be great.
Yeah. I wanted to share another thing as well. Yeah, okay. So let's answer the question of how Julie can be helpful in manufacturing. I'm going with the same data set that I showed you earlier, but first I want to show you a picture, which is a picture of what is being manufactured in this example. And this is a sheet with 300 screen printed carbon electrodes. I've marked the sensors that I have tested, and you'll see it in just a bit why I wanted to show you that. So when we manufacture, we have certain criteria that the sensors need to pass. This includes the peak-to-peak height, peak separation, and highest peak current. And instead of going and selecting all of the different settings that I've showed you earlier, we also have the option to apply a template, which we can just click on this, apply. And we have everything that we need for our analysis. Yes, so let's ignore the small values for a bit. And there we go. We get exactly the same thing that I've gotten earlier, only with a swift click, you can say. And this template option allows any other person than me to apply exactly the same settings that I apply. And this, I would say, it contributes to a more efficient analysis. And we also get these feature checks that I've talked about. And let's talk about the mapping, because what is this? You might ask. And here I pop up the picture that I showed you, and here you can clearly see the resemblance, because here it is each of the sensors that I've tested. And what Julie does is kind of replicate the position of those sensors on the sheet. And it also at the same time compares them to the mean value from that batch and or that sheet. And this can help us trace potential problems or issues in the manufacturing if the results are not as good as we'd hoped. So this is a very helpful visualization, you could say. And the best thing is that it works for 9 sensors, as you see here, but it also works for 300 of them, if we'd like. So overall, this procedure for quality control becomes very quick and easy and user-friendly for great amounts of data from manufacturing. So that's all I wanted to say, Martin. Thank you.
No, I appreciate it. Well, the nice thing is that when Vanessa says, we can do this stuff, what she means is that she does do it. So Vanessa is one of our production engineers. We're going to slightly change pace now. Well, not pace. We're going to try. So far, we've touched upon amperometry, voltammetry. We're going to touch upon impedance spectroscopy now. So if you're working with ZP, we do like voltammetry, but we also like impedance spectroscopy. So I just might ask my colleague. Yeah, brilliant. So Tatiana, if you want to give the guys a kind of introduction to impedance spectroscopy. Don't worry about it, because what I was going to say is we're still going to do a very quick Sensi-All introduction, a very quick Sensi-All demo. So Tatiana, the floor is yours, but don't feel like you have to go for too long, okay?
Okay, sure. Can you hear me? Yeah.
Brilliantly.
Okay, yeah. So here is our report that we collected the data by testing sensors in a sulfide solution at different concentration, and we tested our sensors with electrochemical impedance spectroscopy. So here you can see that we have different lines, different data sets for concentration range from 0 to 80 milligram per liter. We have, this is our impedance graph where we have a magnitude of impedance on the y-axis and frequency logarithm of frequency on the x-axis. These dotted lines are corresponding to our discrete measurement points, and the solid line is our fitted model data. So here it's again the body plot, which is phase versus frequency, another way of representation of the data. And here we have a Nyquist plot, which is an imaginary impedance versus real impedance. So also similar representation of previous graphs, but in another kind of plane. So if I go back to this solid line, so what it means is we are trying to feed our data into the equivalent circuit. And as you can see here, we have a quite often used impedance circuit where we have R0, which is very often referred to the solution impedance. We have R1, which is charge transfer resistance. We also have Warburg element, which is responsible for the diffusion effects in our solution. And we have a C2, which is often double layer capacitance in the system. So what you can see here is we have parameter plot. It's a predicted value of sulfate versus actual concentration of sulfate. And here, if I enable all of the parameters, you can see that, yeah, you can have separation between them. And if you, for example, have a look at R0 value, we can see that there is no actual pattern. The actual values doesn't match predicted values. But if you have a look at Warburg elements, you can actually see quite nice dependencies and possibly limit of detection somewhere around 20 milligram per liter, where you can clearly see the difference between baseline. Here you also have a table which gives you a bit more details on your fitting. You can find the best component. If you look at R² values, you can even sort based on the highest value. And we can see that you have the best values for Warburg, which makes sense because it's a diffusion limited process that you have on interface on your sensor interface. And what I also want to add about the circuit fitting, this is a standard model, but you can always go to the settings, view mode, edit mode, tools, properties, impedance discrete measurements. And here you can always change the configuration of your sensor. So hyphen stands for the series, connection in series, and brackets for parallel connection. And you can always change initial guess, but Julie is quite smart, so it does it for you. So in some other applications, you might need to do it, but here you don't really need to. And if I go back to our graphs, you also have additional statistics that you can get on your fitting. For example, a chi-square here, it shows how well all your data fit into the circuit parameters. You can also see a mean value, standard deviation, and based on the concentration. And if you wish, you can always use the normal approach, let's say, to the data analysis when you just analyze the, for example, phase or direct magnitude of impedance, and you can plot versus the concentration of sulfide. And in some cases, of course, it can be even better than trying to fit into the equivalent circuits. For example, here R² is 0.99, and Warburg element it was even less than that, 0.93. So yeah, it's up to you, but Julie is very capable of providing these nice statistics and analysis, and used very wide ZP, especially for immunosensor testing and characterization.
Yeah, excellent. I mean, that's a really good point. So thank you, Tatiana. I mean, we do use EIS quite a bit. Tatiana just said it. If we're doing a immunoassay where we kind of, often we have an antibody and an antigen binds to the surface, and so really modifies the surface, then we use impedance spectroscopy quite a bit. What I like about impedance and what I like about voltammetry is it's feature rich. I think Tatiana's presentation was quite good because she said, well, here's the data. I can either use equivalence modeling and actually the Warburg element was very strong, or what was also called the R2 value, or the charge transfer resistance, or I can throw all of that electrochemistry out the window, just use an empirical observation and just look at the raw data. So we can either kind of go in the electrochemistry direction, or just say, we're dumb, let's be data scientists, we don't know anything about electrochemistry, and just look at it that way. But you get so much data per test, you can then, I want to say, fish around for the strongest part of the raw data that correlates with the concentration. And then, of course, you want to go and confirm that a few times. And so you don't want to just be, statistically lucky, let's say. We do need to prove it. What I'm going to do now is I'm going to slightly change gears, just do a quick time check. Yeah. So we're going to, tomorrow there's a dedicated webinar on Sense-it-all. So Sense-it-all, we're actually going to put a dedicated webinar on Sense-it-all. But some of you are familiar with Sense-it-all. If you're not familiar with it, Sense-it-all is really our way of, it integrates with Julie as the first thing. It's a conduit or a way of making a minimally viable product really quite quickly. And I say we, I think you're kind of meeting the engineers that really do this kind of work around the table today. But it allows us to, we make a really good screen printed electrode. Why is that? Because Vanessa showed you how much we've actually put into the effort of knowing about our electrodes so that we can actually understand our manufacturing and get control of it. I think we've got one of the best insights into the manufacturing of screen printed electrodes, I would say, in the world. So we make good electrodes, we make good sensors, we make a very robust, not robust, but a very kind of flexible instrument that's completely controlled from an app. There's a Sense-it-all app. We can download it. We can use a QR code to reskin the app for a client or for ourselves. And the app will tell the meter what to do. The app will get the data back. The app will send the data to Julie, which is really important, because if you're working remotely with us, or you're using a clinician to gather some data, we'll always get the raw data. The app will give you the signal after it's gone through a calibration effort, but also the raw data will actually go in the cloud, into the cloud as well. So what I'm going to do then is I'm going to stop sharing for a second. I will ask my colleague Anna to come online, and Anna will do a quick demonstration. Like I say, if you want to see a bit more on Sense-it-all, there is another webinar tomorrow. And I'm sorry that I haven't got a link for it now, but we're dedicating a webinar to Sense-it-all tomorrow. Anna, are you there?
Yeah, give me 1 second, please.
Yeah, no sweat. Hello, good afternoon.
Yo, sorry, I'm just having problems with connection. Just give me.
Yeah, no sweat. So if you're having problems connecting to that Wi-Fi, then hopefully you can get it fixed. But what we'll do is Ghana will try and run through the workflow of the Sense-it-all. So I know it's a sort of, I've already said it, but are you feeling good now?
Yeah, everything's okay. Thank you, Martin.
No
hi,
sweat.
everyone. I'm Ghana. I'm an engineer here in Zimmer & Peacock. Today, I'll demonstrate our Sense-it-all device and also talk about the Sense-it-all platform. Today, actually, I have the new device with me. So here's how it looks like. And the first thing I will do, I will connect via USB-C cable, and then press the button for 2 seconds. Yeah, now the device is connected, and you see the blue line, which is blinking, and it means that it's ready to be connected to the mobile phone. So I have a mobile phone with me, and the first thing that app asks to do is to scan the QR code. So I'll just scan it right now. Yeah. Yeah, so the app now is configured for Ginger sensor because we are going to test Ginger solution. So I already prepared the solution today morning. It's a ginger shot mixed with a buffer solution, 1:10 ratio. And we will try to measure and see how much ginger output we have inside the solution. So what will I do now? I will connect to the device from the mobile phone. I'll click the Bluetooth icon and then wait till the app recognizes and finds the device. It might take a couple of seconds depending which device we are using. So yeah, now here it is. I'll just click to the device and then connect it. Yeah, now everything is ready. But before that, I can go to the test settings and set the test name. I'll just call it test 2, and the cluster name, I'll call it demo. So these are the details that will be shown in the Julie. So I can press the back button, and now everything is ready for the measurement. I'll press to go to save, and then here are the instructions. The first thing that I have to do is to select the dilution factor. We have multiple options, but I'll choose 10 because my solution is 1:10 ratio. Then I'll just insert the cartridge. Now it looks like this. I'll just insert it inside the device and click it up. Yeah. And I will apply 50 microliter of solution.
As you do that, I'm slightly laughing because I realize we've got a black box on a black.
Oh, I'm sorry.
No, it's okay. It's a black.
Yeah.
It's the case is black and the tablecloth is black. But,
Yeah.
but it's beautiful. So it's beautifully small. It comes in a very elegant iPhone black, let's say. But yeah, so you're just putting the sample on now. Great. And the dilution factors just happens to be with this assay. Not every assay requires it. But go ahead. I'll turn my camera off again.
Yeah, I'll just start the measurement now. And it's going to take approximately 30 seconds. So during this time, the device runs a cyclic voltammetry and sends the data to the mobile app, and the mobile app sends it to Julie, where the data is getting analyzed. And once it's analyzed, it sends the results back to the mobile app. So 9 seconds to go, and the results hopefully will be on the screen. Yeah, results are shown already. So we got around 2000 micromolar concentration. I'll just press done, and then now I'll show how the data looks on the Julie. Can you see my screen?
Yeah, we definitely see your screen. Yeah. So I appreciate what's happened then. So the data's gone up to Julie and you're just refreshing. Is that right?
Yeah, I'll just refresh and then choose the device. Now this is the MAC address of our device. I'll just choose this one. And then there is a test tube because I named it as test tube. Let's just click on it. And yeah, here is our cyclic voltammetry data. And here are the results of analyzing. So we're analyzing sometimes one of these peaks, sometimes multiple of them, and get the results to the mobile app. I think that's all. Thank you.
No, I appreciate it. Thanks, Gayana. I mean, what's significant about that is that let's say you were doing a clinical trial or you were working with, with some investors, they will see on their phone a number. So, all very good, but you actually get the raw data as well. So, the raw data allows you to do kind of quality control. Later on, you can try out better algorithms actually, and to try and improve, let's say, the calibration. But it means that it's not just a number. There is actually the raw signal behind the number as well. So I think we essentially want to. I want to sort of say that we'll summarize up now. So I've given you a quick introduction to Julie. Julie is getting old now. She's older than some of my children. We've been a long time in development, but full of functionality. The problem is that she's so full of functionality that we do have to kind of do these webinars just to give you even a sense of what's going on. But it can deal with all sorts of electrochemical data. Today we have shown you voltammetry. It was cyclic voltammetry. It can deal with amperometry. And it can also deal with kind of, almost two ends of the spectrum in terms of assay development, and we were using it in manufacturing as well to kind of make sure that our manufacturing is kind of repeatable. It can also obviously deal with impedance spectroscopy. So if we're working with you or you're working on your own, sometimes we'll actually go, we don't care whether the assay is done by voltammetry, square wave voltammetry, differential pulse voltammetry, impedance spectroscopy. The reason we don't care is because We just want to use the method that gives us the strongest signal. But you can see that we can deal with all of these techniques, and Julie's, you know, set up to kind of crunch through these things pretty quickly. Guyana showed you that actually we use Julie in manufacturing and R&D, but really when we go to minimally viable product, which I would say Sense It All is, for some of you, could be your minimally viable product, you'll give a really nice experience to, as I say, an investor or a partner company, but you actually then get the data into Julie as well. So it really clicks into that kind of MVP stage as well. So I want to thanks, Guyana, for that. Everyone spoke very fast today. We put a lot of information into a 45-minute slot. This is recorded. Give us this evening, and we'll download the video, and we'll upload it, and we'll send you all a personal link to this. So thank you to the ZP team. They came in from the UK and Norway today. The guys in Norway stayed late to do this, so a special thank you to them. And thank you to you guys who were our guests and came along today. Many of you will have hopefully contact details for us, and you can reach out with any questions. And I do recognize your name, so I know who you are. Okay, thanks so much. Thank you, ZP team, and thank you, guests. It's appreciated. And no sweat. Thank you for the thanks. It's appreciated. All right, take care and have a good rest of the day.